Stanford University.
Okay, welcome again to our Revs program series on cars, past, present, and future. It's good to see you all again. I hope you had a great Thanksgiving break. Some logistical issues. This is our last major speaker, John Stanfield here from Local Motion. John was in the design program, as it's now called, in the engineering school, which is the unit outfit program, master's program that David Kelly runs. And you finished there 2 years ago, correct? Yep. And then went on to what people do in this part of the world, of course, which is a startup. And you're going to tell us about that tonight. Yes. Again, as normal, I'm not going to dig further and into introductions and all sorts. We'll find out all about John's stuff from chatting with him and hearing what he's got to say now. Thank you, John.
Sure. Great. Well, hello, everyone. Thanks a lot for coming. I'm tonight going to talk about my company, Local Motion, and where it came from, give you a brief history, and then kind of discuss what I feel the future of ownership is, the direction the future of ownership is headed for automobiles in this country and globally, in my opinion. And I'd love to just open that up to question and answer and just a discussion in the second half of the talk. I don't want to drone on too long, but I have some nice pictures to show you. I think you'll be interested in them. A lot of people here interested in vehicles. So Local Motion is kind of the afterthought of a company called Wang Motors that I started in my last quarter in the design school here at Stanford. Wang stands for where everyone needs to go. What I set out to do was to really shatter the image of the automobile, build an object that looked similar enough to a car, but was different enough that really made people kind of question what its use was. So being in the design school, I was surrounded by brilliant people. I grabbed 4 of my colleagues and posed a question, which was, can we build a plug-in electric vehicle, 4 wheels, from off-the-shelf components in less than 10 weeks for less than $10,000? So we started building, and well, first of all, we started drawing and posing a lot of questions. The question that inspired me the most was, does anyone in here, can anyone give me an answer? How many trips in the US do you think are for less than 5 miles? Anyone have a guess? Half? An eighth? 93%. 93%. Well, that's pretty close. It's actually 1/3 of all the trips that we do as US citizens are less than 5 miles, which is pretty astounding if you think about it, because generally we're all driving internal combustion, single occupancy cars for those trips, which is kind of absurd in my opinion. And if you look at it very closely, that's over 1 trillion miles a year that are traveled in trips less than 5 miles, which is pretty crazy. We're driving 4,000-pound cars, usually with one person in them, moving 200 pounds of mass with a 4,000-pound car for 5-mile trips. So that's kind of what motivated me as a designer to really look at this from a vehicle perspective. So I gathered the group together and we started to draw. And through long sessions of drawing and discussing in the loft in the design school, come up with some very interesting ideas about a vehicle that was open but attractive to people. So when you saw it, you wanted to interact with it and really kind of push product design as we were taught in the D school. Built some models, and then we did what we do best, which was we started to build. So we spent a lot of long hours in the shop at Stanford, bending, welding, cutting, you name it. At one point, this is the frame of the chassis of the vehicle. At one point, we didn't like the front end construction, so we cut it in half and flipped it over and welded it back on, and it was perfect. Interesting. So we pushed that and came up with a design that we really liked, nailed it down, and built it. And the process was quite amazing. I was very fortunate to work with some super talented people, and we actually were able to build the vehicle in about 8 weeks for about $6,500. And this is, clean sheet of paper, completely different than anything anyone had ever seen. The vehicle itself has hub motors in the back. It has a modern lithium pack in the front. It's actually steer-by-wire and drive-by-wire, so very nerdy. We're a bunch of dorky engineers. And so it got a lot of attention around campus as we're driving it around, as you can imagine. And the vehicle itself, there's all the parts after they came back from their various finishing, and this is the final vehicle. So what it really did was it allowed us to manifest all of our thoughts about local mobility into an object and give us a point to talk from. So very different. Like I said, we really like the steel and the wood just to kind of grab people's attention, and we got a lot of very polarized opinions. I mean, people would come up to us and be, and say, hey, that's the coolest thing I've seen in a long time, and then the next person would walk up and say, great job, you built an ugly golf cart. But that's when you really know from a designer's perspective that you've hit a nerve, that you've really found something that people are passionate about, is when you get these polarized opinions. So Lightspeed Ventures came to us, which is pretty cool because they're a big venture capital firm here in Stanfield Road, and they offered us a summer grant. And the summer grant was designed to help students or young entrepreneurs really study the market with some direction. And so we took that money gladly, and the group of us, we grabbed an MBA student for the summer, and we studied the market. And what we determined is that there's a giant hole in the product landscape between golf cart and highway electric vehicle. And so I was fortunate enough to be introduced to a very talented car designer who worked at Audi for 16 years, and to meet my co-founder very early on, Clement Giers. And when people told me in the beginning that team is everything, I really didn't know what that meant. But I met these two gentlemen, and the company basically is what it is today because of the three of us and the founding team. So Toby worked at Audi for 16 years drawing cars, and he left Audi to do other things. He was dying to draw some more cars. I was dying to have someone draw cars for me, so it worked out well. So Clement was really passionate about mobility from a different perspective, and that's more of the optimization of systems. He's an economist and an applied mathematician from France, of all places. And so he was really looking at mobility from a software perspective, if you will. And so I took my ideas and my hardware drive and his software ideas, and we put them together to form Local Motion. And that's where Local Motion started. So Toby and I kept drawing. Here's the first kind of second rev of the platform. So we stayed with no top, just to kind of push that design to where it could go. It's very beautiful. Again, very polarizing. People loved it, people hated it, but it was something to talk about. We went back to the drawing board and said, okay, we need something that's actually safe, first of all, from a perceived safety perspective and from an engineering safety perspective. So this vehicle, obviously, if you get in a crash, you're dead, similar to a golf cart. So back to the drawing board again, but this got a lot of attention. This is Rev 3, I believe. Yep, Rev 3. And you can see that the top of the vehicle has evolved now. This is the same material that NASCAR uses for 200, 250 mile an hour crashes. It's just tube steel. So it's very, very robust chassis. The design kind of ethic here was we bounce off, we don't crush, so everybody lives, but it's a whole nother scenario when you start to go really fast. But the design of this vehicle is always meant to stay off of the highway. So it's a low speed vehicle, meaning it's legal on streets posted 35 miles an hour or less. It's a city car. So it was never intended to go on the highway. There's a huge unmet need for that sort of mobility, as I discussed before. So we pushed this design out even further, and this is actually the final version of the vehicle. So about the time that we got the renderings and the CAD dialed in, I was lucky enough to bring on the first employee of Local Motion, which was Trip Vest. He's also a fellow Stanford mechanical engineering graduate. And he and I sat down and turned this drawing, this rendering, into an actual CAD model. And those of you know what that is. It means that you have now a blueprint of how to build the car. And so we went out to the venture community and looked for money, and they told us we were crazy. And we said, okay, and we kept looking, and we finally found some angels that believed in us enough to cough up some money, and we locked down the design, and we actually built this. And we have this in our shop now. It's street legal, and it's pretty cool to drive around. But at the same time, I mentioned Trip. I met Arnaud and Mike. This is our team right now. Arnaud and Mike are both software engineers, and so Clement was able to work with them and really develop the business side of software, basically optimizing systems for local mobility. And so the two were now running in parallel as they are today. So we pushed forward with the design. Here's a wooden mock-up that we built. We wanted to see if the proportions were right, so we took the designs and actually built it out of a soft material. This took about 5 or 6 hours to build. And from this, we were able to derive all the H points where your hips are actually going to sit in the vehicle and the seating position and all the good dynamics of the car. And at the time, we were actually working in Clement's garage in East Palo Alto. which was really exciting as sirens go by and then the winter rolled in. But we actually, as you can see the clutter, we ordered all the drivetrain components and everything started to fill up in the garage. We actually built the entire drivetrain on a test bench in the garage and got everything working. And then we found some partners down in Sunnyvale that would help us with some shop space, and we actually built out the suspension and the chassis, all of our own design. This is a shot of everything in the car before we started building the tube top. And that's the whole team there. Actually, Mike and Arnaud came for 2 weeks. They're French as well. So before we got the visas worked out, they came on a tourist visa and then had to go back. So before they left, we actually drove it around in the streets of San Francisco, which was quite exciting, just like that. So we found another partner in Santa Clara who would help us with the tubes. And we spent a little bit of our angel money on building the tube setup around the vehicle, forming all the fiberglass, getting everything painted. And here's the product. So this is actually at the launch festival in San Francisco. We presented this to about 10,000 people, and everybody was just kind of blown away. Nobody really knew what to say or think. So the idea of this vehicle, again, is local. And as you can see, there's an LED screen in the front, which would show where the vehicle was going 15 minutes before the ride. You could actually get on the web and book this thing. Our vision was there'd be pods of these around in the cities or on a campus. And it would be a very social, shareable object, which I'll talk more about that in a few minutes. This is actually President Shimon Peres at the launch festival. We took him for a ride. He thought it was pretty cool, which was exciting for us, Secret Service people everywhere. But we got some good lip service and some good press out of the car. So why did we build it, and what does that mean? The idea was to build a vehicle that's low cost, that meets the need of local mobility and is safe and robust and fun to use. So we went out to the venture community after we built it. We drove it up Sand Hill Road and talked to all the VCs. And everybody said, look, I love what you're doing, but I don't want to fund another car company. And we heard that enough times that finally we listened. And we decided to actually step away from the car for a few weeks and actually see what we had learned. So what we did was we basically brushed away all the learning and realized that, one more click of the mouse, realized that the shareable aspect of this vehicle was the biggest learning that we had gained from this process. And what I mean by that is, today, if you kind of take a look at what's going on, people call it the sharing economy. There are different labels for it, but you have social and business sharing of information, personal information, business information with the big names, Facebook and Google, and Spotify and Groupon and LinkedIn. You have living and travel where people are sharing their houses. People are starting to share big ticket items now, where you put your house on Airbnb and you can make money by renting it out when you're away. People are starting to trust each other through these social networks because there's so much information about each other flowing around that you kind of feel like, well, I might know you through my friend who's a friend with this person, but that gives me a trust loop, so I'm willing to share my house with you, which is a questionable thing to do, but it's taking off in the younger generations. And then if we look at transportation, which is, of course, where we were dealing, we started looking very closely at all the sharing models. Now, the sharing models are really interesting to us because of a couple big kind of ticket items. One is, people are moving to cities, and there's a lot of projections about how many people are going to be in these dense urban environments. And really, it just doesn't make sense to own a car in a big city. We actually did a calculation where if you take Paris, for example, and you look at all the streets in Paris in the city center, and you look at how many people are in Paris right now, and if every single one of those people had a car, you'd have to stack them 3 deep on every surface street in Paris to have enough space for the cars alone. So it just doesn't make sense anymore, and that number is growing and growing and growing. So when when these super cities and mega cities in Asia start to develop more and more, we need to start sharing these assets and helping people move around. So the big question is, how do we get people out of their cars? And what we really just learned from our work was we need to build better transportation networks. And there are lots of transportation networks that already exist that can be optimized, which is very interesting to us with our technology. So the keys to that is these networks need to be integrated. This is all my opinion, of course, so if anyone has an opposition, please speak up. They need to be integrated, and what I mean is they have to be smart vehicles. They have to understand what you need and where you need to go ahead of time so that you don't have to wait or have any pain in the process, or humans will just do what they know, and that is use their own car. And what we're trying to do right now is to integrate into people's work life, so into their calendars, into their existing planned life, so that we know where the cars would need to be in time and in place. And they need to be trustworthy. So when you walk outside the door of your office or of your house and you need to go from point A to point B, we need to make sure there's a vehicle there or some form of transportation. And the way we do that is by paying attention to the patterns during the day of where people go and what type of transportation they're using, so that we can then make sure that that transportation is available or an alternate solution that you trust. So this is all very high level, and I'll get down into the details a little bit more here in a few minutes. So we really wanted to learn from the others in the industry. So we went out and we studied and studied and studied. And the very interesting thing is Zipcar is the largest car sharing company in the world. They have 10,000 cars. That might seem like a lot of cars, but really, there are 254 million cars in the United States alone. So it's just a tiny fraction of the available infrastructure is actually shareable. If you include all the other players in the car sharing space in the United States, there might be 15,000 shareable cars. That's really not that helpful. So what we really wanted to do was to look at a market that could make very big change from the get-go with a technology change. And so what we learned was fleets in this country, meaning corporate fleets, commercial fleets, government fleets, there are 2 million highway cars, so passenger cars, in this country alone that are designed to be shareable. But the problem is there really has been no technology revolution in the past 25 years, well, since the inception of fleets, to really help people share these fleets of cars. They're out there, they're unoptimized, they're generally overpopulated, costing a lot of money and pain to the users. So what we really wanted to do was to rethink this transportation system and take what we learned from building what we think is the most social shareable vehicle ever from the ground up, take the technology out of that car that can be used in any vehicle, and now we are retrofitting any vehicle from an electric bicycle to a highway shuttle, a 50-person highway shuttle. So our technology package basically is a retrofit kit now for any vehicle. So that kit, we have to find a place where there are lots of cars, lots of users, and a big problem. And what we noticed was right here in our backyard, there are a lot of corporate campuses. There are a lot of places with 7 to 15,000 people that go to the same place every single day. They all have shareable fleets already on their campus, and they're spending a lot of money. Generally, it's one person making the decision on what sort of mobility they have on their campus. And so we're starting with corporate campuses. Our first customer is actually Google. And so if you think about a campus right now, Google, for example, has about 15,000 people on their campus every day. They have about 200 shared cars. And this is Google, one of the most technologically advanced companies in the world. The way they share their cars is that the owner, or whoever the car is issued to, has the key in his drawer or in his pocket or on a nail on the wall, and there's a clipboard hanging somewhere. And this is how Stanford does it as well. And so the person's supposed to sign the vehicle out, find the key, go use it, return it, which never happens. So what generally happens is the cars sit idle 95% of the time. They just sit in the parking lot because no one knows they exist, no one knows how to use them. So what we really want to do is to change that system with our technology so that, as I mentioned, when the Googler walks out of the door now, there's a car right there ready for them. They take it and off they go. No pain, no thinking, just mobility. And so that's our obsession right now. So any questions so far? I'm just kind of babbling on up here.
Has anyone thought about having the roads movable? Like...
The roads movable?
Yeah. From here to there, instead of all the cars, you just get on them.
Right, like in airports.
Well, but kind of, but it would be for cars.
Right. That sounds great.
I mean, can't we push buttons?
We can push buttons. I think there's definitely the question was, can't we make the roads movable instead of actually using the cars?
Like, not all the roads, but let's
Sure.
say San Jose to San Francisco, so you'd hop on and...
Yeah. So I think to your point, and I can touch on this later, I've done a lot of studying in the autonomous vehicle sector, and the laws and the regulations are changing now, so that within, it depends on who you talk to, within 10 years or so, we'll actually have cars that you just get in and push a button and they take you to where you need to go. So very similar to what you're saying.
Well,
It's
that's
still a car, but you're not actually driving. So
yeah, no, I meant like you're on a not a treadmill, but whatever those
Yeah.
like what ripped my finger off. Whatever those.
yeah, sure, like a treadmill, yeah.
Yeah. What?
Conveyor belt, yeah.
Thank you.
No one's actually done that, so you should patent that idea and start your own company.
I just want to share
You
it.
should do a startup, I think.
Oh, God.
So basically what we've done, just to kind of wrap this up, is we've made a unique piece of hardware that goes in any vehicle. It allows campus inhabitants, I guess you'd say, to walk to the vehicle with their corporate ID. So everybody who works on a campus, most Stanford students have a badge with an RFID tag in it that allows you into buildings. It gives you access to things. It has a little chip in it that has a code. Same deal with us. We put a device in the car. We hack into the car. Now you can walk to the car, tap the green light, it unlocks the doors, you get in. We know who you are. We can track where you're going, so that in the future we can make sure that your mobility needs are met. So we're basically gathering information about how people move so that we can offer a better solution. So that's basically our obsession with the company is our secret sauce is making the user experience clever enough and fun enough that people want to use the system, which in turn gives us the data we need to make the predictions for peak movement, which feeds back into using and leveraging the existing infrastructure so that we can make the whole circle go around and around and around. And I feel that that is what car sharing or other vehicle sharing type organizations, even mass transit today, is really missing, is that they're not looking at it from the user's perspective, they're looking at it from the car's perspective. And what I mean specifically is Zipcar, for example, they make the most money when all of us take independent individual cars, where what we're saying is we really want to look at this from the perspective of the person and say, okay, it might be a use case where you need to use your own car, but generally speaking, you're probably going to a place that's right at or close to where these two and myself need to go. If I only knew you were going, I'd go with you, and now we have 4 people in the same car, which is optimizing the system, lowering the need for cars and the footprint of everything. So that's basically the focus of the company now, and since we've made that change, we've actually been able to raise a round of funding, and we're off to the races. So we're on the right direction. So build better transportation networks is basically the end all of this. So that's great. Where do we go from there? If you look at corporate campuses, you just kind of zoom in on a corporate campus at 2 o'clock on a Wednesday. It has the same exact congestion problems as if you zoom in on 4th and Market on a Tuesday. So we're looking at corporate campuses as a petri dish to learn from, to gather information from, and to build our models, and then we'll push back into the private sector as we get better, smarter, and faster, and raise more money. So that's really all I have for the slide projection. I'd like to open it up and
Yeah, sure. So as you go away from your original hardware platform to a software platform, can you enlighten us a little more on how you monetize this? You know, it sounds similar to kind of what David Cameron in London's doing with bicycles, but just give us an idea of what like a user might pay who's going from Google's campus in downtown Mountain View to here in Palo Alto, versus myself who drove from Santa Cruz.
Sure.
Like how do we monetize the two different types of trips?
Right. So on a campus, like I mentioned, it's generally one decision maker writing a check. So they're dealing with the whole fleet, and then the fleet is actually free for the employees or the users to use. So with that model, it's much simpler for us. Right now, we're just charging per vehicle per month. So we'll retrofit the vehicle, we'll charge them for access to our back-end management system, our holding system, all the software stuff that we provide for them, we charge them per vehicle per month. What I want to do, and what we're really playing with now, is a more interesting pricing model where we're actually paid for the employee mile. So if puts the pressure back on us to make the system so good that people want to use it so we can make money. And it allows the employer or the customer to actually see the benefit of that system. So now they're only paying for the miles they actually use, which is very intriguing to HR, to fleet managers, to all sorts of different people. We're really hitting it from 2 sides. One is we're saying we can walk in the door, look at your system, put in our technology, and we can cut your your number of vehicles by 15 to 20% right off the top. So save them, that's a lot of money if you're talking about 200 vehicles at $30,000 a piece. So we can save them a lot of money. And then we're also saying, look, this is a super competitive environment here in Silicon Valley specifically, and we can give your employees a better experience through the mobility and really raise the bar for hiring. So we're coming at it from both perspectives, cost and satisfaction. Good question.
Yeah, so you've got the software. What's happening to your car design? I mean, are you going to eventually, bring it back so that people find it? Because you mentioned appealing, the secret sauce appealing. So I'm assuming that is actually your cute little vehicle that comes back at some point.
Yeah. So what I learned through the whole process, which is kind of painful for me as a product designer, was that the design that I came up with is not the one that is in demand. And that's fine with me now. I completely understand that the vehicle is really not the important part of the system. I think that there is still a huge hole in the product landscape for a small, efficient electric vehicle, non-highway vehicle. But now that I'm in the industry and we're actually, the OEMs are coming to us now. GM, Ford, Chrysler, BMW, and Audi, just name it. They're coming to us for our technology. And it's very interesting to learn what is down the road for them. And it's kind of a merging of those technologies, really. Those OEMs are actually starting to see these trends as well, and they're starting to think about this from the perspective of the product. So what we're hoping to do is by the time these trends come together, our product is mature enough that we can actually start to put our software and small hardware device in OEM vehicles. So that we'll be filling that niche. May not be the design I showed you, but it'll be something that does the exact same thing. And if in the future someone comes to me and says, hey, I want to build your car, I'll definitely say yes. So, yeah.
You were talking about charging by employee miles. Now, how is it set up in terms of benefiting you or the employer if there are 1, 2, 3, or 4 passengers in a single car?
So each employee that moves, however many miles they move, we get paid for those miles. So if there are 4 people in the car, we get paid 4 times as much. But what we're not doing is charging the company for the time the vehicle sits idle. So right now the vehicles sit idle 90-95% of the time, and they're still paying the lease, they're still paying the insurance. So we can actually reduce the number of vehicles. We can have them pay us just for the time they're being used, and it's a win-win situation.
So you can convince them that it's okay for you to get paid 4 times as much when there are 4 people in the car.
That's the magic of the business model. That's what we're testing right now. So I think finding the business model that works is one of the cruxy parts of any startup. So like I said, right now we're keeping it really simple and pricing it such that people are excited to just, no questions asked, go for it. So
I was kind of curious. I was trying to think about what your business was, and I thought of the immediate competitor. You mentioned Zipcar, and right now they're the biggest name in ride sharing and social car things. So basically, what I just imagined your product doing, because I have kind of conceiving it, was you basically built a box that lets you convert any car into a Zipcar, immediately just by installing it, and so you would work with people that wanted to turn their fleets into fleets of Zipcars.
One of the potential channels in the future, you're hitting it, was on the last slide, is whitelisting our technology, white labeling our technology, and licensing it to other companies. Because Zipcar and the majority of all the car sharing companies today, they're mostly a brand company. They really don't have much technology in the car. They have a cool system that unlocks the doors, but really they're not leveraging the fact that they have GPS tracking in the car. They're not doing any sort of analytics on how people move. They're not really paying attention to any sort of pattern building. And our device, I'm not sure if you, I think I kind of skipped over this, but we also have, in the windshield, we have a little beacon. So there's four colors on the beacon. So as I approach the car, if the beacon is glowing green, that means that I can take it. There's no hold, it's no restrictions on the car. I just walk up with my badge, take it, it's done. If it's blue, that means that someone has gone onto our mobile app and done a 30-minute hold, meaning they needed the car in the future. They decided to plan 30 minutes in the future, which is pretty rare from our test case so far. And they went on the mobile app and held the car for 30 minutes, which means that I can't take it. If it's white, that means it's in a ride, meaning that no one else can take it so that I don't get stranded somewhere. And if it's red, it means it's out of service. So we're thinking about this from the user's perspective, from a visual language perspective as well, which nobody else has even considered. So trying to give information to the users before they actually even need it. So now if I'm standing, in the future, if I'm standing, for example, on 10th and Howard in San Francisco, I need to drive somewhere to pick something up or whatever. Any direction I look, on the side of the street, there's probably 15 to 20 cars. 10, 15, 20% of those could be shared objects, but I would never know it without loading each person's individual website on my phone, trying to find that, figure out how to pay for it, how to get the keys, go down this chain of painful events, which force me to do something else. But if I'm standing there and I look out and now I see a green light glowing 3 cars from me, and I know that's a locomotion system, I can walk straight to it without any sort of interaction on the mobile device at all, tap my badge and go. So that's a big innovation for us.
If it's a 40-mile range, how do you deal with charging?
So most trips are very short, and we're keeping track of the charge remotely. So we know when charge is running out. We can actually make decisions to take a car out of service until it's charged. We broadcast that information through our mobile app. So if someone is through the test cases that we're doing, what we're realizing is that no one books and no one cares about the charge in electric cars. They just hop in and go. It's pretty amazing, actually. So what we try to do is to broadcast that information on the mobile app. So if someone actually does care, they can actually look and see, oh, that car only has 12% left. That means it's 4 miles. And we try to give them valuable information. The charging right now is basically you have to plug it in, but actually a lot of our customers are looking at inductive charging pads. So that solves the problem. When you park it in its spot, it's charging. So that is a problem, but we're trying to solve that through basically a gaming dynamic to get people to do what's right and plug the car in. We ruthlessly spam people if they're repeat offenders of not plugging the car back in. We actually, at one point, built a candy launcher that sits in the front of the car so that when people plug the car in, it shoots a piece of candy at them. But that could go either way. So.
I noticed that there are no doors in the car, and also we talked about safety and seat belts. Do you have
Sure. So this was a California car, and it's a show car. We have a full version that is built with skins and doors and heaters and everything. It has to have seat belts. So that vehicle actually has seat belts, headlights, horn, all the regular things an automobile would have. So
in good weather you can remove the door?
Exactly, yeah. It's really cool to drive it around without doors. And the car we actually built, from your toes all the way to the back of the car is glass, and there's no doors. And so as you're driving, you can see the road. It's kind of like riding in a helicopter, which I've done a bit of, and that was kind of some inspiration for me. So, good question.
Yeah, so the cars that are being used are only electric cars. Are they any particular brand, or they're, is it the Volt or something like that? Does Google get a choice of which cars they have, and they're basically just putting your software in them?
Yeah, so we don't buy the cars. They buy the cars, and we retrofit them.
It has to be an electric car.
It doesn't actually. We're vehicle agnostic. We can put it in any vehicle. Yeah, from an electric bike all the way to a highway shuttle.
So if you're going into regular cars, are you using the OBD port to manage, to monitor and manage the systems as well as driver performance?
Yeah, so right now the answer to that is no. Every car has every vehicle has a real base layer of information that you can get without having to reverse engineer their proprietary system. And we're looking at that information, which is very basic information like fault lights and gas in the tank and some very basic things. We're looking at that, but right now the retrofit takes literally 15 minutes. All we're doing is taking power from the OBD2 and tapping into the door lock system so that we can open the doors. In the very near future, we will have a full system that goes into the diagnostics of the vehicle. The beauty of fleets is that generally they're all one type or two types of vehicles. So when we project and look at the fleets we're doing, we can actually do the reverse engineering of those systems beforehand, go in and just do the whole fleet. So there's a lot of information to be gained from the OBD2, and actually the new electric vehicles are producing a lot of information about charge density, how the vehicles are performing and stuff like that you can actually get on a proprietary mobile app that have an open IPO. So we can actually funnel that information into our system and actually just kind of steal it from them, which is legal. So, but yeah, I checked.
Are there privacy restrictions on information you can share from a car's diagnostics?
Yes, there are.
So like I can't, so I'm just hypothetically thinking your system is really big and it's in 1 million cars, and all of a sudden I actually have real provable data that Ford builds crappy cars and the Toyotas are way more reliable because I have all the diagnostic data.
Yeah. Yeah, so you can...
Allowed to say that or should that?
That's a really good question. I don't really know the answer to that, but that'll be something we cross when we get to 1 million cars, which that would be a great question to have to answer. But to answer it bluntly, right now for us, they're all corporate held cars. So really, since the corporations own or lease the cars, they can do whatever they want with them. So we can actually just make sure that's okay with them. And we're actually going as far in corporations as integrating into the corporate calendars. So without having to actually look too much at the diagnostics, we can get great maps built about how people move and where they need to go before they actually move. So trying to predict that beforehand is key for us. Good question, though.
What did you do with the rental car fleets when you looked at the space of automobiles and what they were being used for?
Meaning how did we slice that up?
Yeah.
Yeah, so rental car fleets are really interesting because they fall into that same exact category of nobody really knows how they're used. They drive off the lot. They have a lot of them actually today are going with GPS tracking, but they don't use the data yet. They don't know what to do with it.
I would have thought they'd really be interested in something that you're coming up with, right? And
So they are.
with you to-
Yeah, they're super interested.
right?
They're also very interested in this for pay-as-you-go insurance. So it's kind of creepy, but the direction of insurance, specifically in the rental industry, is they monitor your driving behavior. And if you're driving badly, they'll charge you more money. And if you're driving well, they'll charge you less money. But there's always that who's determining what's good and bad, and where are the parameters drawn, and there's a lot of gray area, and there's a lot of legal issues to deal with before that ever becomes implemented. But you're right, there's a lot of useful information that our system can provide to help the rental companies control their assets more economically. So we're
so close to being a car share
yeah.
business, right? You'd have
Yeah.
to think that at some point they decide they want to compete.
And they have. A couple of the big ones have actually produced their own car sharing type software, but it's really bad. and they're really big companies, and so some of the corporations we're working with actually use systems on their campuses for employees that are based on rental car sharing systems. And one of our customers said, we've been asking for this very simple change in the software for 3 years, and it hasn't happened. And so we took a look at that, and we said, I think that'd take us about 4 days. And so that's the big advantage of being a nimble startup, is that we can actually go in and mine this information and make those changes really quickly and improve the system and just kill those guys because they can't move that fast. Any other questions?
Yeah, for the case of the car sharing business in the city, how does it compare to existing taxi service? Where are the economics advantage or disadvantage compared to conventional taxi service?
Right, so it depends on how you look at the car sharing industry. The two big models are Zipcar versus GetAround, right? GetAround is peer-to-peer, so I'm renting your car. And Zipcar is, Zipcar owns the asset and rents it to you, just like a rental company basically, but it's more of an on-demand system. So if you look at it from the first GetAround's perspective, they don't have to have all those capital expenditures on their books, right? Like they're providing a system, kind of a smaller version of what we do to your car so that I can use it. And then they mostly take care of the billing and the branding. The taxi system, it's interesting because right now there are a couple companies in San Francisco, I don't know if you guys follow the news, but Uber and Lyft and Sidecar, these three companies, have been really pushing what is a taxi and what isn't. So they basically say we're carpooling, but really what they're doing is they're putting a tracking device in someone's personal car, and then if you own that car, you're driving around the city looking for rides, and you have a mobile app that they provide that says, oh, John is looking for a ride at 4th and King in 5 minutes, and then you just drive there, and you're basically a taxi, but you're not. And so there's this big gray area right now. They're getting sued by the labor unions of the taxis, and there's a lot of legalese going on right now. So it's very gray. In car sharing, off-demand car sharing, meaning the car's just parked on the street, it's fine. The biggest problem is that now I have to be able to find your keys or connect with you to figure out how to use the car. I need to figure out the payment system, just the problems that I noted before. So does that answer your question?
Partly, but the taxi thing is what I'm more interested in.
Yeah.
For example, I know how to use a taxi service.
Yeah.
I can call, the car shows up, it gets me where I want to go.
Yeah.
Right. It's straightforward.
Yeah.
They have their apps now to do that kind of thing, right? How can I use a car sharing service?
I see your point.
Really know how.
Yeah, I see your point. Okay. So this kind of goes to what I was speaking about before with our beacon on the car. So one of the big differences with car sharing is that you don't know that that's a shareable asset. So what you would have to do is you would have to do some research and educate yourself beforehand, before you need the vehicle. So for example, avid Zipcar users, when they're traveling from, say I'm going to Boston, I would ahead of time look at where Zipcar pods are before I land, before I even leave. And I would know exactly where those pods are. I would know exactly how to get to them by public transit. I would take my Zipcar card. I would be ready to go. It doesn't help you if you're standing in the center of Boston and you want to use a car, you're not a Zipcar member. And that's what we're saying is, look, there's a huge opportunity here for, it's funny you mentioned taxis, because that's where really the idea of the oldest car sharing system in the world is taxis. Historically they have a light on the top or some sort of beacon, and it's a very simple verbal or nonverbal communication where the light's on, I wave, the light turns off, he pulls over, I get in, I pay him some money to take me where I want to go. It's a very simple system, and that's what we're trying to do, but we're trying to actually take the driver and the whole system of kind of the unpredictable part of that out. So that now we're looking at the patterns of how people move, and we're placing the cars where the needs are, giving them the ability to see the car is available and the system to go and actually use it, very simply. Yeah.
So I know in some cities like Paris, they've done this with bicycles.
Yep.
And the big problem is theft.
Yep.
That people would take the bike and that's it, the bike's gone.
Yep.
So how do you handle the theft problem with the cars?
Well, the beauty of stealing a bike is that you can pick it up and walk away. The biggest problem actually, so the Velib system, the one you're mentioning in Paris, we've looked at very closely. Clement, my co-founder, actually worked on the Velib optimization system for a while, studied it a lot. And the biggest problem they have is vandalism, actually, which is really interesting because people view these vehicles as public domain, which they're really not. But so they just beat them up. And cars, it's a different system, right? Like our system, we really want the car when it's not being used as a shared asset, we want our technology to kind of disappear. So the screen will go dark, there will be no visible branding. So people won't really know that it's a shared asset unless it's calling out for that action. We need to do things to make sure that people can't.
You said there's the beacon, the red, blue.
Yeah, but we darken that. When it's not being used, there's a cover over it, it goes dark. You can see that there's an object there, but it's not screaming out, hey, I'm a shared object. So when it is in shared mode, we need to make sure that people can't easily steal the vehicle. We do have the benefit of having a GPS tracking device in every vehicle. So if someone doesn't have a reservation or doesn't have access to the vehicle with their RFID tag, because the instant they touch that badge onto our reader, we know who that person is and if they have access to that vehicle. And if they don't, we can deny them access by not opening the doors. And to your question in the back, we actually, from the OBD2 port, we can actually get ignition signals to actually tell the car that this person actually has access. So now the door is open, step number one. You get inside, you need a key or another another piece of safety equipment that will allow you to engage the car. So it's a two-step authentication actually.
Okay.
Yeah.
Can I get back to this gentleman's question about the taxi?
Sure.
So the taxi, there's a fee. It's $3 for the drop and so much. So if you're going to go 3 miles, you're going to pay, $7 or something.
Yeah.
So how does that cost compare to what you're charging?
Yeah. So we haven't figured out those cost models yet, but you're taking a lot of infrastructure out of the system, so it'll definitely be lower cost. The big question for us is who owns that asset? Is it a peer-to-peer model where you own the car and I'm using it? Is it a city asset? Is it a private company that's doing this, such as a taxi company, but not? There's a lot of questions there that we still need to answer, and that's one of the biggest reasons we're starting on campuses, is because we don't, in my opinion, none of these car sharing companies have figured any of this out. I mean, Zipcar's been profitable, I think, 1 or 2 years in its 12-year existence, if that. All the other vehicle sharing companies are venture funded, they're not profitable. They have way more cars in the system than they have users. So they haven't figured out the dynamic yet, and that's why we're starting in a different sector to figure that stuff out in an environment where we actually get paid for it. And then we'll take that learning and press it into the urban environment, which I think is a much better way to look at this.
How long does your car live, so to speak? You know, how many miles will you be eventually able to make?
In the design, in my car design?
Yes.
So we predicted about a 40 to 45 mile range in the urban environment. So, I mean, if you think about driving a car at 25 to 35 miles an hour, most people don't want to go more than 10 or 15 minutes. So they're very short trips in that car. And the beauty of electrics is that there are far fewer moving parts. They're much simpler systems, and they're much easier to maintain. So theoretically, no one really knows how long the batteries will last. And thankfully, Tesla is doing a very good job of studying that for us all. But these cars should last much longer than internal combustion cars because there's just far fewer moving parts.
So who's responsible if we crash or damage a car?
So another beauty of corporate campuses is that they own the assets. They're self-insured, and all the employees using the assets that they own are insured under their insurance policy. So they're responsible for it, not us. We're just helping them optimize the assets they already have. In the private sector, it's a different story, and that's something we'll have to figure out as we go. But there are, Berkshire Hathaway is doing a lot of insurance policies for car sharing right now, and there are a couple insurance companies that are really taking this as kind of their future, and they're doing a pay-as-you-go kind of model, which is very innovative, and I think that's the direction that everything is going to go. So I don't think that's a huge problem.
Do users of your car have like a personal profile for themselves? Is that how it works?
Yeah, so we initially, that was exactly what we're thinking of doing, is everybody, they can customize their vehicle. They could actually, publish where they're going ahead of time so that, I could see that you're going there and I could jump on a ride. Like I mentioned, in our vehicle, we had an LED screen in the front that 15 minutes beforehand, it says, I'm going to destination X. And that means that now it's kind of a hybrid between a car share and a shuttle system. As you see, a lot of the shuttles, the public buses they project where they're going on the front of the bus. So now you can go online and get that information. You can get a visual indication of that. And we even went as far as putting indicator lights on each seat. So now I see where it's going. I walk up with my badge, I touch, and I just sit on one of the empty seats and wait for someone to drive me there, which is my favorite scenario because I hate to drive. So.
Okay, so the reason I ask is because I feel like that's a very interesting feature for insurance involved. Because right now, I guess in California, I think that insurance follows the car, not the driver. So it doesn't matter if you borrow your friend's car and crash it. He has to go then get money out of you.
Yeah.
But if you were having a profile, your profile was loaded, and you were the driver,
yeah,
you could have your insurance attached to your profile, so that when you drove around, but that would be that just wouldn't work in California, how it currently works.
Well, that's to your question. That's what insurance companies are trying to do right now is kind of cut out the whole profile thing and just say, we're actually watching how the car is reacting to your inputs, and we're charging you for those inputs. So if you're driving erratically, you pay more, basically. And that's actually being worked on a lot right now. It's kind of the next generation of insurance policies in the auto world. Yeah.
So I'm trying to envision this functioning on the campus. So is there one person is the driver, and so then they pick up somebody, but then they get off, but this other person wants to continue, so then that person goes and he becomes the driver. Is that how it works? And it just keeps going driver to driver, and they shuttle it around, and somebody leaves it somewhere?
So right now we're doing very simple A to A trips, meaning the driver starts here, goes, does what they need to do, and brings it back to the station. Very soon we're going to implement A to B, which means we're basically going to open stations up around campuses so that we can connect the dots. And then we'll incentivize people to bring the cars back. So basically, since we have a mobile app in everybody's hand and we have a little communication device in every car, we can actually play games with people and try to incentivize them. Hey, it's peak hours. We know there's going to be a big event over on this side of campus. Can the three of you take 3 independent cars instead of ride in one? Basic information transfer through text, through email, stuff like that. Right now, the way it works is, the use case is I'm sitting at my desk. What we found is that the majority of decisions that are made about mobility, the action of actually moving, are done within 30 minutes of the event. So most people don't plan more than 30 minutes ahead, is what I'm saying, which is predictable if you think about your patterns. you get up, you're so used to using your vehicle how you want to use it, you just get up, grab the keys, and go. So we don't want to change those people's behaviors. We want to really incentivize them to continue doing the same thing and morph our system to accept that. So as the cars are moving around, we're collecting that information. We know where people need to go during the day, and we just make sure that we shuttle those vehicles around appropriately. So whenever I walk out the front door, there's a vehicle there waiting. We're very, very interested in the dynamics of sharing and how people actually get together through the mobility. So connecting people to places and events. So what we are doing for the future of this is we are looking forward in calendar or in predicted events on these campuses, so that we can now say, okay, we know that these 10 people have whatever meeting across campus every Wednesday. They should never have to look for a vehicle. It should always be 2 or 3 vehicles right there waiting for them at that time on that day. And if there isn't, we will know that that demand is happening, and we can then call a cab for them, or we can fill that hole with something that's predictable. And so that's how we want to make the service completely seamless.
One of the big problems in campuses like universities is there is no space to park. So if you leave, then you are, it's lotto game.
Yeah.
When you come back, your spot is gone.
Yeah.
So this would really prevent this type of thing. Right?
Yeah, and the beauty of in campuses, it's such a great use case. I hate to talk about it so much, but I studied Stanford very closely. There are over 400 small electric vehicles running around this campus right now. And most of those vehicles park not in designated parking spaces, but close to the facility that they're assigned to. So they might have 2 or 3 cars, in one spot or whatever. They don't really park them legally. They park them by the charger, stuff like that. So you really get prime parking with these small electric vehicles. And that's why they're so great for a campus environment, is that it solves that problem. There's a cord reel where the electric charger is, so they park right next to that, and they're designated spots. So it's perfect for campuses, it really is. And then when you start talking about shared internal combustion cars, it's a little more complicated, but generally those, if the university owns them, there are designated spots for them. And so it's much easier to track and predict. So yeah, campus fleets are awesome.
When you're doing your A to B trip scenarios, are you going to need to provide 1 or more drivers just to go around moving cars to where they need to be?
Probably initially we will, yeah. We call them jockeys, and it hopefully will be a low-cost Stanford intern driving cars around. It'd be a fun job, right? Have an electric bike and just move cars around all day. But yes, that is definitely what we'll do in the beginning. We basically just need to generate enough mobility, enough pattern predictive mobility that we can actually gain the data to build our models. And there are a couple ways to do that. One is hire some jockeys. The other is have on-demand cabs that we pay for. Other systems that we can just really help people fill the gaps until we figure out how to do it through our algorithms.
Or until the cars are autonomous drivers.
That's the best case scenario, yeah. We've talked a lot to the Google Autonomous group, and they're super psyched about what we're doing, but they're building autonomous cars, so they don't have much time. There's actually a guy, the affiliate MIT, I can't remember which state in India he's in, but he's doing focused on small golf cart autonomy. And it's actually really interesting to us. I've been talking to him a lot about trying to bring some of his systems to the United States, because it'd be perfect for campus environments on private land like Stanford, where you could get away with a lot more kind of unregulated actions like autonomy, stuff like that. So super interesting stuff happening in the next 5 to 10 years in autonomous driving. Well, great. Yep.
I just wanted to comment, I kind of found it humorous that your initial goal for starting the thing was, the problem was you had a 2,000 pound piece of, or a 4,000 pound machine moving 200 pounds of flesh. The eventual system that's evolved hypothetically might have an empty car so that it can relocate, so you have 0 pounds.
That's very true, yeah. It's very true. Very true. It's kind of the necessary evil to get to the predictive model, but yeah, I agree with you. It's kind of funny. Anybody else?
We'll take a break in a moment. I just want to pick up on something that stuck in my mind. So Zipcar's been around over a decade, and it's only got 10,000 cars. And you mentioned there's only 15,000 in the US. Total.
Give or take, yeah.
So it's not working. And it's not working, presumably. Well, why?
Yeah, so two things I think. One is, like I mentioned, they're really looking at it from the car's perspective. So the business model is inherently flawed, in my opinion. When you have a system that's designed to be shared, but there's no incentive to share the object, then it just can't work. So Zipcar, for example, we studied very closely the pods here on Stanford campus, and luckily, Stanford students are smart, and they develop their own systems for sharing. They use Google Docs, they use PayPal to pay, they fill the holes that Zipcar is missing. But from my perspective, like, that should be the focus before they do anything else, is like, how do you incentivize, how do you really make sure that you're filling the car with people and make it a social event? Then you're drawing more people to your system. And so maybe 1 out of 5 rides are social and shared, and 4 out of 5 are not. And they still end up making more money. So the system from Zipcar, from my perspective about Zipcar, is that they're focused on getting all of us in an independent car, an individual car. And that's how they make the most money, but that's just a flaw. So the other problem with Zipcar is that they have all these vehicles on their books. They have to own, maintain, fuel, clean all these vehicles. The peer-to-peer model is much more interesting, but
which is the company you mentioned? The company for peer-to-peer.
Get Around.
Get Around.
Wheels is another one.
Yeah.
There are 4 or 5 venture-funded companies right now that are trying to crack the peer-to-peer model. I think Wheels is doing a great job. They're actually looking at campuses. Initially, they're here on Stanford campus. They're trying to really connect students through personally owned cars. They're also funded by Zipcar. They have a big piece of their funding came from Zipcar. So I think Zipcar's kind of looking at them as their technology developer. I don't want to go too far into the politics of all this, but they're kind of just right in the same alley as Zipcar and the technology. They're focused on the car. And so, my opinion is that those guys, a lot of those companies, they really need to look at how they're fundamentally sharing the vehicle with people versus just getting people in the car, getting one person in the car. Does that make sense?
Oh, yeah. So the issue that is at the heart of it is the sharing, okay? Yeah. And indeed, there are other components that you're pulling out on the ownership, Yeah. What I'm kind of circling around as well is a big issue, historical issue really as well, about the shared commons. The old issue of commonly held resources, facilities, whatever it might be, and how they can be or not be successful or taken up and how they decay. You mentioned one, which is the issue of people not caring about stuff that isn't necessarily their property.
Yeah.
And that can lead to all sorts of issues of vandalism and theft and stuff like that, or whatever. But so sharing seems like a good thing, okay? But clearly it hasn't taken off with the likes of Zipcar. So forgive me for just probing a bit further, because it would seem to me that, okay, whatever Zipcar are doing, getting right, getting wrong, if you have a service which is, I don't know enough about it because I don't do it. I can rent a Zipcar, or I can just take a one. Is it that people just don't want to share? That's what I'm kind of getting to.
Yeah.
It's not that Zipcar just aren't good at getting sharing. It's just maybe people don't want to share at all.
Well, so that's a very interesting point. I feel that my generation, I'm almost 40 years old, and my generation, when I turned 16, you were in the line at the DMV to get your license. Cars are a big deal. They're your freedom. They're your sign of maturity. They're a rite of passage, if you will. And that's not the case anymore. I mean, the first time 16-year-old driving license is down almost 20%. That's amazing. It's a lot of kids not getting their license. 17-year-olds, I think it's like 17% it's down. There's just a trend of people not owning cars as they have in the past. The ownership model's changing. So I think the sharing economies are coming. It's going to take a generation or two for that to really hit. The other interesting thing is, as I put them on my slides, are people are getting used to sharing large, expensive assets, and so that whole image of either that's mine and I don't want to share it, or I don't want to share somebody else's object, that's going away. And so these models, these vehicle sharing models, will become somebody's going to crack the egg, and it will be successful, in my opinion, because it's normal now to share things.
think it's the question or the problem that Zipcar is trying to solve, and not to put words in your mouth, but
Sure.
the problem you're trying to solve are different issues. Like the way I think of Zipcar is that it's for the urbanite who doesn't own a car that wants to borrow one to go to Costco. You know, and so I need a car for a couple of hours, then I'm going to bring it back. And so, and it's not so much that I don't want to share, but it's that trip doesn't happen for enough people often enough to make Zipcar really take off the way that they perhaps thought it would. The issue that you're solving is a little bit different in the mobility around a campus, not so much to run, to Costco and back for a person living at home. And then
Sure, yeah.
I think there's still a third one we haven't really touched, which is the commute problem.
Yeah.
Of how do I get from wherever I live to that campus?
Yeah.
And it's, that's probably not Zipcar, because I don't want to pay the entire time that Zipcar's away from its Zipcar home, if I go pick it up and drop it at work for 8 hours.
Yeah.
And then bring it back. I don't want to pay for the 10 hours that I've got a Zipcar.
So the third one is very interesting, the peak hour commute. We've been working with Google they have about a third of their employees live within 6 or 7 miles of campus. It's a lot of people. They have about 20,000 employees here in Mountain View. So finding small efficient vehicles that we can put our system on to incentivize, hey, I live over here and I can pick a couple people up on the way to campus. Now I'm on campus and this vehicle becomes a distributed model all day. And then at the end of the day, we're managing all the behind the scenes stuff. This vehicle is stashed with enough charge on it to get the same person home. And so it solves kind of two of those with one. And that's super interesting to us because similar things happen in the city. And back to the Velib system, the bike sharing in Paris, one of the biggest issues with it is that a lot of the commutes are downhill. And so people get on the bikes and they ride them downhill and all the bikes are in the energy hole in the bottom of the hill and no one rides them back up. So they actually have full-time crews of trucks that sweep the bikes up and pull them back up to the top of the hill. And they have this is what Clement was working on, is some gaming dynamics that incentivize people to ride the bikes back up the hill. And you have people that will game it, right? People that are bored or have a day off in the middle of the week, they'll ride 6 or 7 bikes up to the top of the hill and get enough credit that they don't have to pay for a Velib for 2 months, stuff like that, which is really interesting behavior to note. So, yeah, so you're right. There are definitely some very kind of subtle differences between the systems, and I didn't go into that very deeply, but I feel like with an appropriately smart system, if you will, you can solve some of those problems together. Yeah.
Well, you talked about the fact that we don't plan in advance, and 30 minutes is sort of the best you're going to get, and that's going to make the sharing that much harder because one person's 30 minutes starts now, someone else's starts 15 minutes later, and all of a sudden they're not together.
Yeah.
You might want to take something from the jitney model from other countries where you're able to flag something down, not see it parked on the street, but just be out there thinking, gee, I'd like to go there, and there's some vehicle going my way, I'd rather ride than walk, and be able to do that mutual identification.
Our joke is that we're going to give everybody, those in NFL football games, those big foam fingers. We're going to give everybody one of those so that when they're walking around, they can just wave it and say, hey, I'm in the system, pick me up. So yeah, you're right on track. Yeah, there's a lot of, and that goes back to the gaming. And the beauty of having a mobile app is that, you can do a lot of these things on the mobile device through cues or, buzzes or sounds or whatever to really let people know what's happening around them very subtly. And that's super exciting to us because there's a lot of space there to innovate in. Joe, do you have a question?
I was going to offer a comment that we're talking about these new systems in the context of today, but as time goes forward, as congestion increases, as insurance rates increase, as laws change, as it becomes more oppressive for the current alternatives, that is ownership or whatever, a lot of these other things are going to look a lot more advantageous to us.
Yeah, it's very true. Yeah, it's very true.
I'm just curious, is there any commonality here? This is a horizontal model, and I know elevator traffic, there's been a lot of analysis there about what to do and how to stack them and how to get people moving.
Yeah.
Is there any research there that can help you?
That's a good question, actually. I've never compared that. I looked at that briefly, actually, when I was here at Stanford. It's really interesting, actually, because some of the elevator companies have actually taken advantage of people counting and RFID reading to really model that very well. So it's interesting, actually. I don't know.
Well, they've done the thing now where there's an elevator that only goes to a certain set of floors.
Yeah.
And then
Express lane.
And then they've done double stacking of elevators, and
Yeah.
the whole traffic flow thing is quite complicated.
Yeah, for
I don't
sure.
know if there's anything there that.
I don't know. That's a good question. Yeah. Have to hire someone to do that.
Okay, let's take our 10-minute break now, and then we'll come back, and I've got a bunch of things I'd like to open up again. Okay, let's start up again. Gosh, got a bunch of issues here. But John, I want to. The contrast, of course, in the two parts of your talk is very, very interesting. And you're not to know this, but of course. But this quarter, we've had all sorts of different perspectives on, the history of cars and why people, love to collect them or, just hang out with them and work them, on them, and all sorts. I just want to ask you a couple of questions about your experience with that. With making your car, because
Sure.
you built this thing, right?
Yep.
And so it seems to me, tell me a little bit more about your background as to how, that clear enthusiasm, passion for, the workshop and building cars, where did that come from?
Well, actually, I grew up on a farm, and
Yeah.
by the time I was 16, I had driven everything from a snowcat to a D6 earth mover, and so I've always been around vehicles, and I built cars and restored cars and, tried to tweak them, and I've blown them up and all that sort of thing. So just kind of always worked on vehicles. And then I studied physics in my undergrad and built a lot of things in the shops there, learned how to, machine and turn and all the kind of techniques that you need to build a vehicle, and just continually have built things. And when I came to Stanford, one of the things that drew me to this department was that the shop was right next to my building. And I was actually a TA for the 2 years I was here. I was a TA in the PRL, and so I had access to the full tool set. And so when we were here building, it was great because I had a key to the door and I could just go in and use the lathe when I wanted to at midnight or whatever. And so yeah, that's kind of where it all started.
So what did it feel like when, it became clear that line that you were following with this fabulous thing you'd built, and all the design, all the thought that had gone into it, when it, I'd like to hear how the funders, the venture capitalists said, no way, or this is just so far off our mark.
Well, all you have to do is look at the history of electric vehicles in Silicon Valley. And there's a kind of a road that's just littered with the carcasses of dead electric vehicle companies. There's been one or two that have made it, and the one that's most prevalent has about, depends on who's counting, but just less than $1 billion of investment so far. And that's Tesla.
Yeah.
The founder is very wealthy, and that's not me. So I couldn't self-fund the company. So we had to go out to the venture community, and I feel that the venture community is an amazing filter to where the trends are going. That's what they do for a living. They study trends, and so eventually we had to listen to them, and really through getting to know a lot of these, Tim Draper and the guys at Rockport and Venrock, and the big investors, really, they'll speak to you in a tone they'll never say no to you, but they'll strongly suggest a direction. And so after a while, we're like, okay, we get it. And if we really want to make a big change, we can actually take the technology that we've built and apply it to a much greater set of vehicles and a much greater set of users, and actually really do more change than trying to build a niche vehicle. For me personally, it was a huge relief, because there were two of us building this car, and we did it in about 2.5 months. And it was, after I slept a while and thought about it, it was actually quite a huge relief to think, okay, I can focus on the human-centered design of actually what gets people to share vehicles and share objects. I can focus on a very small in-vehicle experience, and we can really do the software very, very well. And to build a car company with 5 people is quite a task.
But the common component is this interest in, this commitment to human-centered design. Because that's how you started out with building that particular car. It was to find a solution to an issue, a problem that people have. And your line was, okay, focus on the car. And so really it's not that much of a, in a sense, shift in enthusiasm, because it's the same kind of thing.
Yeah.
Yeah.
We tried to open the conversation between the 5 of us that built the first vehicle here at Stanford. We tried to open the conversation completely open. Like, we tried to look at this from a human-centered perspective. We did not set out to build a car, to be honest. We started looking at mobility and what it would mean to actually try and solve a piece of local mobility. And we looked at apps, we looked at electric bikes, we looked at scooters, we looked at all sorts of different solutions from software to hardware. And what we realized through a lot of study was that you need an object that is familiar enough to people, that speaks a visual language that they already understand, so that when they approach a vehicle or they approach a solution, they can look at it and know how it works. And there's no questions asked, because any sort of learning curve puts friction in the system and forces people back to the solution that they already are using. And so our first vehicle is arguably that, but we kind of did that on purpose. But the next vehicle, the second vehicle we built, when you walk to it, you see a steering wheel, you see 2 pedals, you see a seat, you see a seat belt, and if you have a driving license, you know how to use it before you even touch it. So that was really key for us. And so now, taking our technology into any other vehicles, it's the exact same deal. It actually just opens our market up.
Now, you've mentioned that you're getting interest now from car companies who are, you're suspecting or maybe even know, well, they're going to be interested in this kind of thing because it's a trend, a future, and whatever. But with the previous, with this car that would come between the golf cart and the highway vehicle, and there is clearly a gap there. Was there not an interest from car companies?
Oh, absolutely.
In that?
Absolutely. Yeah. The biggest problem with car companies is that they don't want to take a risk on their brand.
Yeah. On their brand.
On their brand. Yeah, they're very thin margin companies that rely on high volume, and if they produce an object that people are like, what is that? And it's a big risk for a Volkswagen or for whoever, big automaker, to build something that didn't come out of their design shop. It's a huge risk. And so most vehicle companies looked at that and said, okay, what can we learn from what you've done, instead of can we build your vehicle?
Yeah.
And it's the same thing, Tesla's a great example. Like, they're building a car that looks like a lot of other cars, and they've had a lot of trouble getting started. So the branding issue is really, I think, paramount.
Because to me it seemed that it might be that, the approach you'd taken, which was kind of bottom up, we're going to rethink, a vehicle. Mm-hmm. In terms of weight, materials, and everything like that. It could be that that's just, wow, so far out of the way that you build a production line for vehicles. Typically, the production lines that car companies typically build.
Yeah.
So the amount of investment there is, or just it's a mismatch.
Yeah. Well, another good example is the global electric motor car, the GEM. There's a bunch of them on the Stanford campus. General Motors started building those as a CAFE fuel offset. So they basically, the administration 10 years ago said, okay, car companies, you have to raise your fuel standard to this by this date. And so the car companies, of course, have really talented lawyers who looked at that system and said, okay, what can we do to minimally change our system and still meet the standard? Well, we can just build a vehicle that gets 150 miles to the gallon, which is a golf cart, let it drive on the street, and then we meet the overall standard, and we can keep building SUVs, which are a high profit margin device. And so they did, and it worked for years. And the GEM is a total piece of crap, pardon my language, but they built exactly what they needed to do to occupy that movement, and they created this vehicle that now is used for things they didn't anticipate it being used for. People are driving them on the street. People are driving them around. They're really cool. But GM, after they lost the interest of that, and the standards changed again, and they actually had to make more efficient vehicles, they sold GM to Polaris, and now Polaris. It'll be really interesting to see what Polaris does with that.
Yeah. One of the kind of issues that I think applies to big industries like the car industry is, well, you've kind of touched on it with, you need to. It's not that incremental change is the only kind of change that will take place. But certainly any kind of major disruptive design changes are very, very difficult to bring about, if not impossible.
Yeah.
I'm very interested that you say that there's a kind of branding issue in that, which is kind of like, what the company stands for, as well as the obvious, financial and engineering components to it too. It's just very, very difficult to make a major change.
Yeah.
Yeah. Are there any comments at this point on some of these issues?
I think something that Joe actually mentioned earlier that's really interesting to me as well is, companies such as PG&E, Joe mentioned, that have a very kind of different array of vehicles, meaning they have Honda Accord natural gas, and they have 4-ton 16-wheel pole movers, stuff like that, and it's interesting to look at the kind of extreme ends of that fleet scenario where you have a truck that is designed to do one or two things, and there are 25 to 30 people that are using it, and because the fact that no one really knows who's using what and where it is, because they're not truly shared assets, they have 4 of them instead of 1. Yeah. And so you're using, you're burning all that fuel, you're using all that infrastructure to create it, they're spending all that money to buy multiple units, and that's kind of across the board in the efficiency changes that I see coming in the near future.
Yeah. Let's move on then a little bit to some of the issues in your, well, as someone put it, it's a shift from hardware to software solutions to this. It kind of works. That's kind of nice. The sharing business. Okay, now you said that the story you gave us was, that your potential funders are saying, well, we're not going to fund another car company. So was it go away and think about it, or was it that, we know that the trend is towards, sharing and all that kind of stuff that you came to focus on?
So we were actually building the system in parallel. We were actually I was building the car, Clement and Arnaud were building the software. And so we were pushing both things forward at the same time. Yeah. And so when we would go present, we would present both things. We're saying, hey, we have this car that's actually just an open operating system to run our software. It's a rolling sensor. We have cameras, we have motion sensors, we have acoustic sensors. So we're taking the heartbeat of the city, we're funneling all that information back to our back-end servers, running it through our algorithms to give people information about how people are moving around and trying to share assets. And they said, why do you need to build cars to do that? And we said, because cars are cool. I mean, I've given the argument for why that needs to exist, and I still believe it does. But in the mind of a venture capitalist, it's like you go after the solution that's the lowest cost, capital-wise, and so that's exactly what we did.
But what you have also done, which I found very interesting, is you avoided what some of the criticisms of the future of mobility are, which the criticisms are that it's going to change the driving experience, and it's just not going to be as attractive as it was. Okay? And we've circled around that a good number of times over the last few weeks. But what you've actually done is, in a very neat way, is you've kept a focus precisely on the experience of being with cars. It's not necessarily the motoring experience of the open road or whatever, but that's not within your brief. You've much more focused. And so you focused in on making the experience of sharing the cars as attractive as it can be.
Yeah, I really think that in order for this to work, we have to make sharing cars more interesting than owning cars. We have to make the experience of using a shared car better than using your own car. And when we can accomplish that, then it's a natural shift.
If your cars are Ferraris, then you're set.
Sorry?
If all your cars are Ferraris or Lamborghinis, then sharing won't be a problem.
Yeah.
Well, no, but you see, if you change your focus from campus services essentially, why can't you have other kinds of shared experience which are on different kinds? You see what I mean? The focus on experience is common to all of them. So you can shift attention and have a model that would allow, the ownership not to be the deciding factor in the fabulous motoring experience, but the motoring experience. and here's a way of getting a pool of Ferraris that are efficiently shared.
John might be actually able to tell us. There was a startup that was into letting people who own luxury vehicles share them, and there was this gang who planned it and stole 3 cars in one day, and the CEO sent out an email the next day saying we're shutting down.
I'm not aware of that.
It was on TechCrunch.
Oh, interesting.
A few months ago.
Yeah.
But they catered only to like exclusive luxury cars.
Interesting.
It was like get around basically.
Yeah. There's a question right back
here.
Regarding sharing.
Sorry?
I had a question regarding sharing. Do you have any data which would lend you to believe that a certain age group and also profession might be more willing to share, as well as gender? Because I was talking to another lady, and I'm older now, and I don't think I want to share. I'm sorry, not always. I want to have my own vehicle, even though it's painful because you can't find a parking spot. Sometimes I would like to share, but not as a usual
Sure.
thing.
Yeah, so yes, there definitely is some narrowing demographics for that. And as the data starts to be more prevalent through the other car sharing systems, we can see trends. And it mostly is younger demographic, to be honest. It's mostly, the 18 to 30-year-olds that are either in a urban center, such as a city, or on a campus. I'm not sure on the sex. To be honest, I don't know the answer to that.
And I wonder if it's not worthwhile focusing on that group.
That's why we're on corporate
And
campuses.
also, like you say, campus or other big cities.
So the beauty of campuses, another beauty of campuses is that if you look at the people that work there, it's generally that demographic that lives in cities that are sharing cars. So it's basically a big circle. So
you're not tackling the old professors then. The students, the young students.
We're trying to, but Stanford moves so slowly, it's just painful. We've been talking to Stanford, we're like, hey, we're right here, we have this cool stuff, and they're like,
Here's some more comments. Yes.
Please speak up just a little
Yes,
bit.
sure. Sorry about that.
I had a question. If you'd, I guess you have a lot of data on the different sort of driving profiles for people. Do you have good data on who screws up cars the most? Like,
Yes,
bracket?
that's very widely published. It's
What can you do with it? Like,
it's
are you allowed to then charge more to this bracket
well,
based on their profile?
insurance companies already do that. I mean, if
The
you,
younger you are.
it's males between the age of 16 and 28, the most dangerous human on the earth. I mean, single males, yeah, it's incredible. If you look at the stat, I mean, I don't have to pull from my data. Just go to the crash data from the Department of Transportation, and I mean, you're already getting overpriced for insurance. You're already paying more of a premium just because of who you are.
Absolutely. I was just curious from like a discrimination basis. They probably have some weird deal that they're allowed to do that, but are you allowed to do that? Are you allowed to say you're this, you get charged more when you borrow a car?
Right, potentially, and that'll be something we'll have to figure out as we go. We don't have enough data to make a valid call on that yet, but really that boils back down to for us in our current model, the insurance, because we're not charging the individuals who are using right now. We're charging the campus per month, so they're able to let whoever they want use the vehicle. So if there is a danger area, I'm sure they can tell us, and then we'll restrict those people.
I was just visualizing you working with like a startup that is largely guys in Mountain View, and they get charged twice.
Believe me.
Female startup gets charged or something like that. I just don't know if that's.
Yeah, I don't. I'm not sure. I think we'll leave that to the insurance companies for now.
One of the benefits of the technology that John is talking about, and you mentioned it earlier when he was talking, is the insurance companies moving toward this model where they track individual drivers and insure you based upon your own driving habits. Because right now what we're talking about is you're lumped together with everybody else in your age group. You could be a terrific, safe driver, but you're going to pay the penalty if you're in the age group of all the people who have the most accidents. But if they have specific data on you, on just your car and your driving, and you can demonstrate to them through that data that you're a better driver, theoretically the insurance companies could offer you lower rates.
So you're saying the insurance companies can be as good as current FICO scores?
Yes.
Well, I'm not,
That's a mess. But yeah.
the capability is there. Whether they will do it and whether they will be customer oriented is a different person.
Yeah, for sure.
Yeah.
I was wondering if any public bus system has approached you to optimize their system, having smaller vehicles, more routes, dynamic, fewer stops, exact same technology to optimize the public bus system.
Yeah, so I'm not sure if you're familiar with, there's an electric bus company called Proterra. They're building electric buses, basically. They are by far the leader in the field, and we've been talking to them quite a lot. There's a lot of interesting things we can do. We have a system built, actually, a very smart system that sits on the doors of the buses that counts people coming in and out, and we incentivize tapping of RFID so we know exactly who the people are. We can monitor on the system while it's in use. So yes, we're talking to a few. The existing public transit systems, basically they get a contract for 5 or 6 years and then they're in motion. And you can't really do anything with them while they're in motion. So that's a much more inherently complicated system just because of the bureaucracy of the cities and who's running those systems. But
it doesn't necessarily need to be an electric bus.
No, I agree, yeah.
Big bus could be a variety of vehicles,
Yeah.
gas or electric, just optimized with the technology so that this shared experience can be also optimized with fewer stops, faster, anything. I mean, the technology can offer a lot.
I agree, yeah, I agree.
Make it more efficient.
So we're starting with the campus model. We're starting with, most campuses now have shuttle buses that pull their employees back and forth from San Francisco to Silicon Valley. And so it gives us a great opportunity to actually test our models with larger systems, with different shaped systems, I call it, there. So exactly to what you're talking about, we're exploring a way to actually offer the shareability of information about the transit system. So, for example, you alluded to fewer stops. So if there's no one at the stop, we would know it, you wouldn't have to stop. Or if the bus is being late, you'll get a clever notification. Or if you're walking to the stop and you're going to miss your bus, we'll then notify you, hey, hurry up. Simple things like that, which don't really exist today for corporate employees. And that applies directly to public transit in the future.
So there must be a large amount of data that your system is doing. Do you have very much hardware to manage this? I mean, I'm just curious, do you have 3 people, the software on 3 computers or lots of computers, or how does that work?
Yeah, I mean, it's the beauty of the modern computing age is we can just rent that server space. I don't know where it is, but we're renting it from, Amazon or whoever, yeah. It's really cheap these days to rent server space, so.
Yeah.
I'm not much of a psychologist, but I think part of this is about the nature of sharing, especially the earlier comments. And one of the things I observe is even in kind of the shared transportation spaces, we're not very good at it. When you get on the Caltrain, you put your bag down in the seat next to you, so no one else will sit there. You're trying to claim your row, and it seems to me that that's public transit. I think even towards some of the themes we've been talking about, the single commuter in their car might be the last analog to, kind of the lone rider on the prairie. It's the last completely private space where, we are by ourselves. We're not as alone at home nor at work. The car is the last place where we can pick our nose and sing along with the radio, and we pretend we're in a bubble that no one else sees us doing that. But that once
pretend or hope.
We pretend and hope, both at the same time, right? And I think there's sort of I'll be curious to see what the shift is that needs to happen when we, lose that last bubble, or what that behavior becomes when I feel like we don't like sharing, even though if we acknowledge that it's an inevitability and it's a thing that's coming, right?
Yeah, I have a 1.5-year-old, and it's something you have to teach. Sharing. It's not something that comes naturally.
Well, it's chosen sharing. Like someone cute gets on the train and all those bags are immediately disappear.
It's totally true, and it's out of necessity as well. I mean, I'm sure you've traveled and you go to a city where public transit actually works, and that's not the case. I mean, there's just every seat is taken and there's standing room only, and sometimes not even that. You go to Piccadilly Circus on a commute hour day, and it's lucky if you get on the train. And then you go to places in India and you literally don't get on the train for hours. I mean, it's just a matter of density, and that's changing so quickly. So, you know, we're in a bubble here, don't forget, on the Bay Area. Like, there are a lot of things that don't exist anywhere else, but all that is changing. I mean, it's...
But I mean, even with that, I mean, I accept that, but we do our best to contain our own...
Agreed.
You know, like, you put your iPad, you know, like you put your iPhone, you know, like, I may not even be listening to anything. I just don't want anyone to talk to me, you know, like, I'm going to pretend I'm listening to something and I can't hear you.
It's funny, we were just talking about this in the shop the other day, like, what is the action that you need to take to break that dynamic, and is there something you can do? I'm obsessed with the inside of public spaces, actually. It's kind of my latest thing to detract me from what I do, just to have some sanity. And think about when you're on a public bus and you're tuned out, you're in your own world, what is it that I need to do to get your attention? If I'm sitting next to you, or if I'm a company trying to get information to you, what is it that I need to do to get your attention? And we're playing around a lot with the space inside of buses, advertising, stuff like that. With our system, you know, we can actually tell how many people are on the bus. We know approximately where the bus is within a 5-meter radius, so we know what's around it, so we can channel information to people that they could actually use, which is a whole nother part of our business model. That
I'd suggest people with tinfoil on their heads, because they pay attention to that guy a lot.
But isn't the opposite true? If you're sitting on the bus, you want to be in your own space. You don't want somebody to be intruding on you.
Yeah, but I mean, the beauty of being on a public bus is that you're driving down city streets, and everybody has needs. Everybody has shopping needs. Everybody has medical needs, and you know, on your commute, you're passing hundreds of retail establishments, and you probably, because you're tuning out, you don't even know that. Right. And so it is definitely a shift in the norm to knock people out of that kind of tunnel they're in, and that's, I don't have a solution yet, but that's one of the things I've been obsessing about recently.
Yeah.
I'm wondering if you're giving any thought to the fact that we live in an area now where they have wipes when you grab a shopping cart, and you know, you don't touch a doorknob in the bathroom. And now you're going into a car and you don't know who was in there before you, and that kind of cleanliness issue. Is that
yeah, it's definitely an issue, and Zipcar actually spends a lot of money keeping the cars clean. But I think, you know, it's kind of like riding public transit. If you're that person, you probably don't ride public transit, because you just can't control all those variables. But I think it's a good friend of mine has a really nice car in the city, and it's very interesting. He has it on two of the peer-to-peer sharing models, and he said his car's never been cleaner, and he doesn't clean it because people use his car. It's a nice car, so they bring it back and they feel guilty, and they stop by and like vacuum it out on their way home from Tahoe or whatever, and his car's always clean and always full of gas. And he's like, this is great. I'm making money and my car's clean. And so it kind of goes against what you would initially think. So it's really interesting. The sharing dynamic is not a simple dynamic. Whenever you put humans involved, it inherently gets complicated. So it's a good point, but I think it's unclear yet.
Well, we are at our finishing time. So, John, thank you very much. I think it's a great end to our series of talks with a really refreshing, I think, and human vision of where we might go with our cars.
Well, thanks for having me.
Thank you so much. Thank you.
Great. Thanks for having me.
For more, please visit us at stanford.edu.